In this video, let us talk about some of the ETL challenges faced by engineers while moving MongoDB data into a warehouse like Redshift or BigQuery. Before we begin, let me tell you a bit about MongoDB. MongoDB, as you may already know, is an open-source document-oriented database and uses JSON-like documents to store data. MongoDB is very popular among developers building web applications and services owing to its schemaless nature. This gives scope for rapid development and flexible deployments at scale. But the real challenges come when you need to analyze the data stored in MongoDB. Performing extract, transform, and load on MongoDB is quite challenging. Here's what goes wrong. Unlike a relational database, a MongoDB collection doesn't have a predefined schema. Hence, it is impossible to look at a collection and create a compatible table in Redshift up front. For example, one document on users can have just a single name field, whereas the next document can have both first name and last name as fields. This makes it extremely hard to define a schema on Mongo, in turn making the ETL engineer's life really hard. Two documents in a single MongoDB collection can have fields with values of different data types. For example, the field mobile can be both string and a number in the different Mongo documents. Although this is a completely valid state in MongoDB, you will necessarily have to convert it into a string or a number in Redshift, and this becomes a real challenge. It is possible to add columns to a document in MongoDB by running a simple update to the document. In Redshift, however, the process is not straightforward. You have to construct and run alter statements each time a new field is detected. MongoDB doesn't put a limit on the length of the string columns. It has a limit of 16 megabytes on the size of the entire document. However, in Redshift, it is a common practice to restrict string columns to a certain maximum length for better space utilization. Hence, each time you encounter a longer value than expected, you will have to resize the column in Redshift. The most complex of MongoDB ETL problems is handling nested objects and arrays. MongoDB allows nesting objects and arrays at any depth. A complex real-life scenario may become a nightmare trying to flatten such documents into rows and columns for a Redshift table. Not all data types of MongoDB are compatible with Redshift. Object ID, regular expression, and JavaScript are not supported by Redshift. While building an ETL solution from scratch, you'll have to write custom code to handle these data types. In addition to this, you'll also have to spend precious engineering resources to monitor and maintain the setup. Not to mention the engineering time you will have to invest in building a self-serve ETL solution that can cater to the business needs of the entire organization. Let me talk about an easier alternative. A data integration solution like Hevo can easily resolve all the challenges I mentioned before. How? Let me tell you. Hevo dynamically detects schema as it pulls documents for ETL. With each incoming object, Hevo examines its structure and field type and automatically reproduces the schema. As and when it detects new collections and object fields, Hevo automatically creates new columns and tables in Redshift to incorporate the latest schema changes. Hevo also expands the existing varchar columns in Redshift dynamically as and when it encounters longer string values. This ensures that your Redshift space is used wisely without you breaking a sweat. Hevo sends real-time notifications to you whenever fields with incompatible types are detected in a collection. Hevo also allows you to take the appropriate action to handle the incompatibility in real time from within the tool. Hevo lets you split the nested MongoDB documents into multiple rows in Redshift by writing simple Python transformations. This makes MongoDB file flattening a cakewalk for you. Hevo converts all MongoDB data types into the closest compatible data type in Redshift. This eliminates the need to write custom scripts to maintain each data type, in turn making the transition seamless.